Welcome to another Mount Holyoke Psychology Statistics Hub tutorial. This is your lab director, Natasha, with a research question for you. Sleep and academic course load have long been studied as predictors of stress. Imagine Mount Holyoke staff want to learn about whether sleep and course credits can predict the stress levels of Mount Holyoke students. Given our sample of 100 students, are the average nightly hours of sleep students report and the number of course credits a student is enrolled in able to predict the stress level of that student? What analysis can you use to answer this research question? When you have two or more continuous variables and you want to see if you can predict a change in one variable based on change in the other variable or variables, you can use regression. With our data, we will investigate whether we can predict the stress level of a Mount Holyoke College student based on their average nightly hours of sleep the student reports and the number of course credits the student is enrolled in. Each of these variables is continuous. Sleep is the number of hours students reported getting the previous night. Credits is the number of credit hours students report taking this semester, and stress is a self-rated score of how much stress students report on a scale from 1 to 10, with 1 representing very little stress and 10 representing extreme stress. So to run a regression using SPSS, we'll click on Analyze, go down to Regression, and then over to Linear. And the variable list on the left, you're going to find what the dependent variable is. In this case, we're looking at stress levels. So we'll move stress over to the dependent box. And then if you just have one, if you're running a simple regression, you can just put your one variable in the independent. In this case, we have multiple regression, and we're going to put two variables in that box. And those are sleep and credits. So we'll move those over and then hit OK. In the output, the first table that we're interested in is the model summary. That gives us our R value, but also the R square value. And that's the percentage of change in one variable that can be predicted by the model. So in this case, the amount of change in in stress level that can be predicted by the combination of sleep and credits. Then the ANOVA table tells us the F value. It gives us the degrees of freedom between and within, and the mean square error as well. And then the p-value tells us whether or not the model as a whole is significant. In this case, it is. It's below 0.05. So we can say that together, sleep and credits do significantly affect the stress level. And then to get a sense of how each of the variables is contributing to the model, we can go down to the coefficients table. We see here that sleep has a negative coefficient, and that's telling us that as sleep goes down, stress goes up, and vice versa. As sleep goes up, stress goes down. And we can see from the SIG column that it's the p-value is less than 0.05, so that significantly contributes to the overall model. Credits has a positive relationship in that the higher credits you have, the higher stress, and the lower amount of credits you have, the lower stress. But if we look at the p-value, we see that that actually is not significantly contributing to the model. So overall, even though we have a sense of how these variables are affecting the stress level, right now we can just say that both of these do predict a change in your stress level. And so remember, until next time, don't be mean, be above average.